Unit 3, Day 4, homework tutorial. On this lesson, we were proving lines parallel. So I'll work through the odd problems with you. For number 1, it says if the measure of angle 1 is equal to the measure of angle 2, determine which lines are parallel and state the postulate or theorem that justifies your answer. So angle 1 and angle 2 are tied together both by line M. So that means line M is the transversal. So we are going to say R is parallel to S because of the converse of the corresponding angles postulate. This was one of the postulates that is on the blue um, properties sheet that you were given in class, as well as it's one of the properties that was listed on the notes. Because angle 1 and angle 2 are corresponding angles, so that's why we are using the converse of the corresponding angles postulate to prove the lines R is parallel to S. For the next section, it says determine which lines are parallel and state the postulate. So for angles 3 and 7, the transversal would be line L. So that means A is parallel to B. And since those are alternate interior angles, we would say it's the converse of alternate interior angles theorem. Number 5, we're looking at 8 and 9. So that means the transversal is line A. So that means the parallel lines would be L and M. And those are consecutive interior angles. So it would be the converse of the consecutive interior angles theorem. And number 7, we're looking at 10 and 11. The transversal would be line M, which means the parallel lines would be A with B. And again, those are consecutive. So it's the converse of the consecutive interior angle theorem. For number 9 through 13 or 14, I believe, it wants us to find X so that L is parallel with M and identify the postulate or theorem used. So for these two angles in the picture, they're alternate exterior angles, and in order, alternate exterior angles would be congruent. So we would say 5x minus 5 is equal to 6x minus 20. And then solve for x. First, subtract 5x, so that would give me a negative 5 is equal to x minus 20. And then add 20, so 15 is equal to x. And the theorem we used was the converse of the alternate exterior angle theorem. For number 11, these two angles are alternate interior angles, which means they're congruent. So 3x plus 15 is equal to 90. Subtract 15, you would have 3x is equal to 75. Divide by 3, so x is equal to 25. So this was the converse of alternate interior angle theorem. On number 13, these are alternate exterior angles. Again, they're equal, so 2x is equal to 3x minus 20. So we would subtract 3x would give you negative x equals negative 20. Divide by negative 1, so x is equal to 20. And again, this is the converse of the alternate and exterior angles theorem. So now we're going to practice proof writing using some of these new theorems and postulates we just have learned in this unit. So it says, given that angle 1 is congruent to angle 2, so let's mark them congruent on our picture with our arcs. And angle 1 is congruent to angle 3 as well. So let's mark those congruent. So that is our given, because our first statement is always given. So we have congruent angles, and then on statement 2, it's talking about the measurements of my angles are equal, and that's by the definition of congruent angles. And notice now it's saying the measure of angle 2 is equal to the measure of angle 3, and that is by substitution, because angle 2 replaced angle 1 on the left side of that equation. So it was a substitution between lines on line 2. So when you had the measurements are equal and now you're saying the angles are congruent, again, that's the definition of congruent angles. And now that we know angle 3 is congruent to angle 2, and they are on opposite sides but inside, so they are alternate interior angles. But since the angles come first and then the lines, we have to use the converse of the alternate interior angles theorem. If it had mentioned the parallel lines first and then the angles, then we would just use the normal alternate interior angles theorem. So if you use the normal one, the lines have to be mentioned first and then the angles. So 4 and 5 would be flip-flopped. But since they mentioned the angles first and then the lines, we have to write the word converse of in front of the theorem or the postulate. And I hope this tutorial helped you to be able to complete the rest of the problems on this assignment. Good luck.